This lecture is all about single stage common drain MOSFET based amplifier working at mid frequency range. I will explain and derive expression for terminal characteristics of common drain amplifier. I am just referring my 9th and 10th lecture for reviewing small signal equivalent circuits and fundamental of amplifiers. Let us start discussion about common drain amplifier from its characteristics. These are four important characteristics of common drain amplifier. The very first one is it is basically known as source follower. The reason behind its open circuit voltage gain is slightly less than 1. Second point, it has large amount of internal feedback. Only because of this large amount of internal feedback, this gain is slightly less than 1. And in other words, the meaning of source follower means the source potential is smaller than gate potential, or source is following gate potential. Third one is it has high input and low output resistances. That's why this stage is used as a buffer stage. Common drain amplifier is used as a buffer stage for impedance matching. Common drain amplifier is used to couple high input resistance to low output resistances. And as far as structure or circuit diagram of common drain amplifier is concerned, this is very simple circuit diagram, and this is a device, and this is a drain, gate, source, bias resistor, and this is a source resistor, and CC1, CC2 are the coupling capacitances, and because of CC1 coupling capacitor, input voltage source is connected to device. It also blocks DC component coming from signal source to device. This also helps in stabilizing Q or quiescent point of the load line of this device. And at mid frequencies, this will behave as a short circuit. And this coupling capacitor is used to connect output to the load resistor. At mid frequencies, this will act as a short circuit. In that condition, this output voltage will be equal to this output voltage. And this also blocks DC component coming from the device to the load resistance. There are two important points in this diagram. The very first one is signal ground is achieved at the drain terminal. That's why we are not using any resistor connected with the drain terminal. Second point, drain terminal is common to input and output ports because this is called common drain amplifier. On the next page, I will explain how to draw a small signal equivalent circuit for common drain amplifier. Now I will explain how to draw a small signal equivalent circuit of common drain amplifier. This is basic fundamental circuit of common drain amplifier, and this is the most fundamental way of sketching a small signal equivalent circuit for common drain amplifier. This is the input voltage source, and this is the input resistance of input voltage source, and RG is the bias resistor, and VI is the input voltage across RG, and RS is the source resistor, R0 is the output resistance of the device, and output is taken across RS. Now this is in fact current source. This is voltage control current source, and VGS is measured between these 2 points G and S. This is G and this is D and this is S terminals. Now let us have some modification in this circuit. I am converting this VCCS current source into a voltage source by way of interconversion of sources using Thevenin and Norton theorem. And this is voltage control voltage source, and this is voltage source. And little more changes are there. This R0 is here, and I am shifting RS from here to the output position. Now VGS will be measured between these 2 points over here. Now this is G, D comes here, and S is there. D is common to input and output ports. This is common drain amplifier. Now there are 2 planes mentioned over here. This is first plane, this is second plane. Across this plane, between these 2 points looking towards the amplifier, the resistance is called input resistance of the amplifier, known as Ri. Across this plane, between these 2 points looking toward the amplifier, resistance is called total input resistance. Let us have the expression for Ri and Rin. So this is input resistance. Ri is equal to input voltage by input current. Input voltage divided by input current. This is Rg. And Rin is equal to Rs plus Ri. That is Rs plus Rg. So this is the way how to draw a small signal equivalent circuit of common drain amplifier and how to have expressions for input resistances. For the derivation of expression for the output resistance of common drain amplifier, some changes are required in this small signal equivalent circuit of common drain amplifier. Since we are dealing with the dependent sources, we have to use Thevenin equivalent theorem. For that, we have to nullify these input voltage sources. That means we have to replace this voltage source with a short circuit and we have to apply one test voltage across output terminals. On the next page, let us have the modified diagram which will be used for the derivation of expression for the output resistance of common drain amplifier. This is modified small signal equivalent circuit for the derivation of the expression for output resistance of common drain amplifier. As per Thevenin theorem, this input voltage source is short circuited over here, and because of this short circuiting, input current is 0, input voltage across bias resistor is 0, and this is test voltage which is applied across output terminals of the amplifier, and this is source resistor, this is the output resistance of the device, and this is voltage controlled voltage source, and this is one plane. Across this plane between these 2 points looking towards the amplifier, the parameter is known as output resistance of the amplifier, which is denoted by R0. And the potential difference VGS is measured between gate and source, which is in fact the difference between potential across bias and source resistor. And we conventionally write mu G is equal to Gm R0. And the potential difference VGS is equal to Vi minus Vx. Vi is 0, that's why VGS is equal to minus Vx. And considering this loop and applying Kirchhoff voltage law, let us write the expression for output voltage Vx. Between source and drain, the output voltage is Vx, which is equal to the sum of potential difference between these 2 points and across R0. So this Vx is this potential difference and this potential difference, and just putting the expression for individual items and putting the value of Vgx, which is minus Vx, and ultimately this is the expression, this is the final expression for output voltage Vx. From this equation we get equation for I2, this is the expression for current I2 which is passing through R0, and at this point, as source point, using Kirchhoff current law, this Ix output current is equal to sum of I1 and I2. I1 is passing through source resistor, I2 is passing through R0. So output current Ix is equal to I2 plus I1, and writing the expression for I2 and I1, and this is the expression for output current Ix. Now we are in a position to define output resistance R0 of this common drain amplifier, which is the ratio of output voltage to the output current. And this is the expression, there is a minus 1 power. And in fact, the output resistance of common drain amplifier is a combination of 2 resistances in parallel. And we understand one point, 1 plus mu G is greater than R0. That is why the output resistance is very small. This is very usual for source follower because source followers have high input and low output resistance. So this is all about to define and derive the expression for output resistance for common drain amplifier. This is the modified small signal equivalent circuit of common drain amplifier for the derivation of expression for the open circuit voltage gain. This is the input voltage source and this is the input resistance of input voltage source. This is the biasing resistor, this is the source resistor across which output is taken, connected between source and drain terminal. R0 is the output resistance of the device and this is voltage control voltage source, and Vi is the input voltage across biasing resistor. This VGS potential difference is measured between gate and source terminal, which is in fact the difference of potential across biasing and source resistor. Considering this loop and using voltage divider law, we get the expression for output voltage V0. This is the expression. Finally, this is the expression. And VGS is Vi minus V0. From this expression, we get the value of V0. And from this expression, we get the expression for input voltage Vi. Now we have input voltage and output voltage. Now in a position to define open circuit voltage gain AV0. The ratio of output to input voltage is, this is the different successive form, and mu G is Gm R0. Now considering this expression and just consider this factor. This factor is more than 1, then open circuit voltage gain approaches 1, that means unity voltage gain. This is the main characteristic of source follower, where source is following the potential of gate. Anyway, in common drain amplifier, there is no phase reversal of input signal source, and there is no body effect, because in this analysis we have assumed that body and source terminals are interconnected. This was all about working and terminal characteristics of common drain amplifier working at mid frequency range.